it's new to me day, and I have in front of me a Marconi TF2500, which is an audio frequency power meter. So there's a good manual online for these, and I'm just going to read you the general introduction just so you get an idea about what this unit is capable of. So the TF2500 is a battery operated audio wattmeter voltmeter for measuring power in the range of 10 microwatts to 25 watts. And it will do that from 20 hertz to 20 kilohertz. It'll also measure a voltage up to 150 volts, and I think that is AC, it is AC, from 10 hertz to 1 megahertz. So all of that is done by this switch here, and then the function switch at the front. So for power measurement, the amplifier is preceded by a switched input transformer and attenuators, providing 7 power ranges for balanced and unbalanced measurements at any one of 40 input impedances. So that's these switches down here, so there's 10 and then a multiplier as well. For voltage measurement, the input is applied directly to the amplifier, giving 9 voltage ranges, again at high impedance. And again, these are marked here and depending on the function switch. So, as I said, this is a battery operated unit, so it's isolated from the main, so a very useful bit of kit for characterising and measuring amplifiers. Now I already have a couple of these series of meters, and they are very, very good. I've got the TF2600, which is a very sensitive AC meter, and also the 2604, which is a vacuum tube voltmeter, but again very sensitive, very accurate. And what I really like about these is not only the build quality, but also this meter is just a thing of beauty. It's really easy to see and use. And one of the first things I always like to check when I get a new instrument like this, it's always a bit of a lottery obviously when you're buying them online, is whether or not we can adjust the meter so we do actually have some meter connection to the needle, and we do, which is good news. So I think the first order of operation on this is we'll turn it around and we'll have a look at the battery compartment, have a look at whether it's got batteries. I suspect it has because it's really heavy. See what condition they're in, and then we'll go from there and disassemble the case of the instrument, have a look inside, see what it looks like. One really nice thing about this is, even though it's got quite a late calibration, the calibration seals on the back are intact, so I'm kind of hopeful this one hasn't been monkeyed about. Okay, let me turn it round and then let's get the batteries out. Okay, so here's the back of the unit. So battery container, and a thumb screw. Which is the longest screw in the world. They really don't want that one coming out, do they? And then hopefully this should just slide straight out. Yeah, okay, so what have we got? So these are 9 volts, they're DF9s. Obviously in series, series, so they're giving 18 volts, 2 9-volt cells. These are pretty much obsolete now. There are some alternatives around, but they're still difficult to get. I think we'll be, regardless of what these batteries are like now, we will be replacing them. And we'll probably do something creative just to give us our 18 volts. Just as a matter of interest though, let's see whether or not we actually have any voltage in these. Let's see, can you see that? I think you can. Okay. So let's have a look at this one. Look at that, 9.23. And then this one will be the other way round. Okay, that one's a bit low, 7.71. Amazing how these batteries last. They don't go on like they used to, that's for certain sure. Okay, let's I'll get this battery out the way, this battery unit, unplug it, and then let's get this rear cover off and see what we can see. Okay, 2 more big screws. Not quite so long. And hopefully, these are the calibration seals I've broken, but they were intact. Hopefully this whole back will come away. And we have the power resistors. They all look to be okay and intact. There's some very odd values here. 516 ohms, 1.036 kilo ohms, and these are all 1%, so these are some quite specialised resistors. We'll have to have a good look at those, see how they look when we actually come to servicing the machine. But nicely on the heatsink there. It's got a DC output here, and this is actually for use with chart plotters. So it's a very low millivolt output that you could connect a chart plotter to, so you could characterise your instrument and get a print or a plot of what you'd done. Okay, so I think I need to get underneath this now, take the feet off, and then that should allow us to take the case off and we can have a look inside. Okay, so we're looking down on top of the machine now. So this is where all the weight is. This is an enormous transformer. It goes pretty much 2/3 of the way down through the machine. So this is where all the magic happens in terms of transferring, the power and dropping the voltages down so that it can handle the power. Metal case canister on top, so this is coincident with the selector switch on the front, so I guess this is where all of the sensitive stuff is. Let's see if we can prise this off. The answer is no. Okay, let's have a look. Okay, that's a bit trickier than it should be. Don't think there's any clips holding it, are there? There we go. Okay, let's have a little look. So here's our selector switch. Looks pretty clean in here, I have to say. A few electrolytics that will probably need to be checked. I mean, this is a sort of a 60s, 70s instrument. Lots of adjustment pots for calibration. Switch, multi-layer wafer, so all of these will need a good clean. But other than that, I don't see anything too concerning in there. Okay, let's have a look. On this side here, there's nothing. This is just the side of the machine. But there is a board. Oh, God, this is heavy. Here. Let's see, can you see that? Pretty much. So I wonder if this is some sort of attenuation board. Lots of wire wound resistors. Lots of trim pots. But again, looks pretty clean. We'll get into what all these do and how we're going to check them a bit later on. Let's turn the machine upside down. Okay, what can we see here? Lots more wafer switches. So this one I think is the impedance selector, and then this is the multiplier for it. So lots of point-to-point wiring will all need to be checked. These will all need to be cleaned off since the signal is going to go directly through all of these switches. So there's bound to be some corrosion. And then this looks like the power and function selector switch down the bottom here. So here's the bottom of the transformer. More windings come off it. Beautifully made, these instruments, but I mean, they are of their vintage, but on the face of it, not a huge amount that will be of concern, I don't think. I mean, I think I've seen about 2 or 3 electrolytics and that's it. So other than some of these older resistors maybe going a bit out of value, which we'll do a sort of a check of a bunch of them, see how they look. Overall, a nice clean instrument. So that's the first look around this thing. Obviously I've got a bit of work to do, sourcing some new batteries or some new way of powering it. I'll do a little bit of checking over, cleaning all the switches, have a look at some of those electrolytics on the other side, and then hopefully next time you see this, which might be a few days because I've got things to do, but hopefully we can have a look and see whether or not she works and just see how good these meters are. Okay, hope you found that interesting and stay tuned for the next episode.